I talked with Lonnie Simonian about a project that will be directed by his colleague, Dr. Thomas Corman, assistant professor in the Department of Construction Management at California Polytechnic State University at San Luis Obispo. This project will identify the best management practices and benefits of using building information management for electrical contractors. Well, first of all, explain to me what BIM is.
It's a building information modeling, and it is a technique whereby you convey what is commonly done in two-dimensional drawings in a three-dimensional medium. So you take the information that, say, would be presented on drawings, but now you've also added a vertical component to it, and you construct something just like a physical model, but now it's a virtual model because it's a computerized model. But the model is not just a dumb model, it's a smart model in the sense that you embed other information in it. For instance, in a two-dimensional medium, you have lines on paper. In a three-dimensional model, those lines are not just representative of lines, but they could be a wall or a building facade, lighting fixture, and so they actually stand for something and not just pixels on a screen.
Well, explain to me what MEP coordination is.
Okay, so MEP is an acronym used in electrical and mechanical industry. It stands for Mechanical Electrical Plumbing. It encompasses the work that an electrical contractor or a mechanical contractor would perform.
What effect has BIM had on the MEP coordination?
So you've got a drawing that an electrical contractor produced. You've got a drawing that a mechanical contractor produced. And then if you plotted those drawings on something that you could see through like a Mylar, and you lay them on top of each other, it's known as an overlay process, and you put them on a light table, you can actually see where there might be interferences between, say, a mechanical duct and an electrical conduit, where they might hit each other. You wouldn't normally see those on a 2D drawing because it's somewhere in the third-dimensional space. But now through BIM, all that information is stored and the computer actually calculates when there would be a hit.
So how has this also affected electrical prefabrication?
Previously, you'd have to wait at a job site, you'd have to wait for work to be performed, say, by the structural and then by a mechanical contractor, and the electrical contractor would move in after all of this equipment has been put in place, and then they would come in and start putting in their electrical components and equipment. Well, now an electrical contractor can use the model and measure things from the model space rather than the physical space in the field. So they can measure from the model, go to their shop, cut to length various conduit or cabling, prefabricate assemblies, and then when the time comes, go out and just install the assemblies as opposed to building it from scratch at the site.